Hi guys, welcome back. So today I'm going to be showing you guys how to find a derivative using the definition. So we have a simple example today of f at x is equal to x squared. So first of all, for our definition, what we normally do is we substitute uh, the function with f at x plus h in this function, and then minus f of x divided by h. So first of all, we'll go ahead find our f at x plus h. So simply we substitute this f of x plus h in the function, and we get x plus h all squared. And then we have our function, which is f of x is equal to x squared. So our definition of the function will be as follows. So the prime here means the first derivative is equal to limit of h approaching 0, our f of x plus h, whatever we found, we substituted over here, minus our function right here, all divided by h. So we have that. Now what we can do is go ahead and simplify this further, this term, x plus h squared, which will give us x squared plus 2xh plus h squared minus x squared divided by h. So you can see right here, when we simplify x plus h squared, so that means two terms will multiply, two of the same terms will multiply by each other. So x plus h multiplied by x plus h, which will give us x squared plus 2xh plus h squared. So we could take this thing, what we found here, we could substitute it back here, remove that and substitute it, and we'll end up with something that looks like this. Excuse me. So now we know that this x squared is positive and this one is negative. So what we can do is go ahead and cancel this guy out with this guy, because they subtract and there's nothing left. So now we're left with the first derivative is equal to limit of h approaching 0, 2xh plus h squared divided by h. So we're left with something like this. Now we know that we could simplify this further. As we know, there's a h in this first term and h in the second term. So we could take out an h common, and we'll get something that looks like this. So we have f of prime x is equal to limit of h approaching 0. So we took the h common out of here and this term, and we got h times 2x plus h all over h. So what we could do is we could go ahead and cancel this h by this h, right? So we'll be left with something like this. So we have f of prime of x is equal to limit of h approaching 0, 2x plus h. So we'll be left with something like this. So now what we could do is we could take this limit and apply it within the function. So once we apply it, we basically just substitute the 0 wherever we have h terms. So now we're left with the derivative, f of prime of x is equal to 2x plus 0. Normally the 0 means it's the constant, but in this situation we don't write the constant if it's a 0 term. So our derivative would be simply the first derivative of f of x is equal to x squared would be 2x. So you could just simply write f of prime of x is equal to 2x, or you could write y of prime is equal to 2x. These two things, they basically mean the first derivative is equal of this function is 2x, or y prime is equal to 2x. They all mean the first derivative. I hope this video was useful. If you guys found it useful, please give it a thumbs up.